Hi everyone, this is Mr. Cole and welcome to our fourth video on Chapter 9 Ratio and Rate, where we'll study about speed. So in this video, we'll learn about speed, what is average speed, how to convert different units of speed, as well as solve problems relating to speed and algebra. Okay, so some of you may recall, for speed we have to learn a formula, right? So our formula you can remember as speed equals to distance traveled over time taken. Or can you remember this pyramid over here, right? So how do we use this pyramid? Whenever we want to find speed, we'll cover this up, cover the letter S up, which S associated with speed, alright? We'll take distance over time, that's our formula. If we want to find distance, we'll cover distance up. It's actually speed multiplied by time since they are the same level. And if you want to find time taken, we'll cover this up and we can interpret as distance divided by speed. Okay, so this is how we use this triangle to calculate speed and distance or time. So let's look at this question. A driver travels 48 kilometers from his home in Singapore to catch a coastal town. He starts his journey at 9:20 a.m. and reaches his destination at 10:05 a.m. on the same day. Calculate the speed in kilometer per hour and meter per second. So first, okay, when we calculate speed, we first write our formula is the distance divided by time. So we need two information. For the very first part, right, distance, we already got it from the question. It says 48 kilometers. Or we can write it as 48,000 meters. Okay. Next thing, for the time. The time we know it starts from 9:20 a.m. and then goes to 10:05. So let's do by number line. So let's start with 9:20. To go to 10 o'clock, you add 40 minutes. Right, so you have 10 a.m. and then you add another 5 minutes to reach 10:05 a.m. So our total is 45 minutes or 3/4 of an hour. Alright, just by dividing by 60. So that our time will just be 3/4 hour or 45 minutes. Okay. Next, let's calculate the speed in kilometers per hour first. So speed in kilometer per hour. So what we do is we calculate the distance in kilometer and the time in hours and we just divide it. So we have 48 km over 3/4 hour, and this will give us 48 divided by 3/4. We'll get 64 km per hour. Alright, this is the first answer. Our next, speed in meter per second. Okay, we already got the distance in meters, so let's write it down. But then for seconds, alright, we only got minutes so far. So how do we convert minutes to seconds? Yes, we multiply by 60. So we take 48,000 meter over 45 times 60 seconds. Alright? And this will give us a value of 17.7/9 meter per second. Alright? Or if you want to write as improper fraction, it will then be 160/9 meter per second. Is that okay, everyone? Good. Now, how do we convert 30 km per hour to meter per second? Okay, so wherever you are converting units, alright? So we have kilometer per hour, meter per second. Right in fraction form. Alright, fraction form. So what do I mean by that? Okay, so we know that 30 kilometer per hour is actually a rate. So it's 30 kilometer traveling, 30 kilometer per hour means you're traveling 30 km every 1 hour. And how do you write this as a fraction? The slash sign is simply your line in your fraction. So we have 30 km in 1 hour. Agreed? Now, at this juncture here, we just need to recall how do we convert from kilometer to meter. We can do so by multiplying by 100. So let's multiply by 100. And sorry, not 100 but 1000. And this will give us 30,000 meters. Next, from hour to minutes, what do we do? Yes, we will just multiply by 60. So we multiply 60 to the denominator, you get 60 minutes. But that's not our end goal. We want seconds. So what to do next? Okay, we just multiply by another 60. So then we multiply by 60 again. We get 60 times 60 seconds. Okay? In the last part, what do? We just type everything into our calculator. So 30,000 divided by 60 times 60, you will get 25/3 meter per second, or we can write it as a mixed fraction, 1/3 meter per second. Okay, I hope this is okay with everyone. Now, what about the opposite? How do we convert meter per second to kilometer per hour? Okay, simply reverse it. So what we're going to do, same thing, express as a fraction. Okay, so 18 meter per 1 second equals to 18 meter over 1 second. Okay, now if from kilometer to meters we multiply by 1000, then meter to kilometer we just do the opposite, which is dividing by 1000. So then we divide by 1000 and we'll get 18 divided by 1000 kilometers. Okay, but what about seconds to minutes? Same thing, we also divide by 60. Alright, the opposite. So divide by 60. Okay, 1 divided by 60 minutes. Okay, and then we go another step by dividing by another 60. Divide by 60. So get 18 divided by 1000 on top, kilometers. And then in the denominator we put 1 divided by 60 divided by 60 hours. And lastly, we key everything to our calculator. Let's see what we get. Okay, you should get 64.8 kilometer per hour. Okay, is that clear, everyone? Okay, good. Now let's learn about average speed. So for average speed, the formula is similar to what we learned in speed. However, we just add a total in front of both the distance and time taken. Now, why this is very important is because the total time includes the time that the object is under rest or stationary. Okay, so this is very important. If let's say the question involves a car moving and then suddenly it stops and then it moves again, the time taken when it stopped is included in the denominator. Alright, let's look at this question. A cyclist traveled a distance of 90 kilometers. The first 50 kilometers at a speed of 25 km per hour and the remaining distance at a speed of 45 km per hour. Calculate the average speed for his entire journey. So first thing, we write our average speed formula. Average speed is the total distance divided by total time. So let's look at our total distance first. Just nice, the question has given you the total distance is 90 kilometers. However, the total time taken is not given and we must find out. So we got two parts of the journey. First part and the second part. So for the first part, how do we calculate time? Alright, so if we recall our triangle, alright, speed, distance, time. If you want to calculate time, it will be the distance divided by the speed. Alright, so the time for the first part will just be 50 km per hour divided by 25. This will give us 2 hours. Okay, and for the second part of the journey, the time would then be the remaining distance. Alright, so what's the remaining distance? So the remaining distance over the speed. Alright, so this will be 90 minus 50 divided by 45. Okay, and this will be 8/9 hour. Right, so then our total time taken would then be 2 hours and 8/9 hours. Okay, so now let's calculate the average speed together. So the average speed equals to 90 divided by 2 plus 8/9. Okay, let's key this in our calculator. This will give us equals to 405/13 km per hour, or 31/2/13 km per hour. Okay, so notice that our average speed of 31/2/13 of km per hour is actually just nice in between the two speed given in the question, 25 km per hour and 45 km per hour, which makes total sense because our average speed should lie somewhere in between both of the speed. Okay, let's look at a different question. This one actually uses algebra in the question. Okay, a bus travels from city X to Y at an average speed of 50 km per hour. If the bus increases its speed to 65 km per hour, it will arrive at city Y 24 minutes earlier. Calculate the distance between city X and city Y. Now, this question is quite cryptic because if we look at our formula, alright, DST, so speed, distance, time, they only give you the speed and the time difference. They don't give you the total time taken. How are we going to solve this question? So first, let's use algebra and state our unknown. So we first state that let distance between X and Y be small letter, okay, let's say is A. Okay, maybe distance, a better letter would be D. Okay, we want to find out this letter D, unknown D. Okay, for the first journey, alright, the average speed of 50 km per hour. So we know that the time taken, alright, to travel 50 km per hour, okay, so time taken for 50 km per hour journey would then be distance over speed, which is d over 50. Okay, now you may be thinking, why am I doing time taken? You'll soon find out later, but take note, this is in hours. Okay, let's look at the second one at 60 km per hour. The time taken for 65 km per hour journey will also be distance over speed, which gives us a value of d over 65 hours. Now, why did I calculate the time taken for both journeys? This is where we use our final clue of the third part, 24 minutes earlier in the second journey. Can we construct an equation linking these two values together? Okay, so we know that this time taken should be 24 minutes longer than this time taken. So let's construct our algebraic equation. Okay, so let me just shift it around to get more space. But very first thing, let's convert minutes into hours first. So 24 minutes, if we divide by 60, it will get 2 over 5 hours. Okay, so then by linking up both of these and 2 over 5 hours, how should we express it in terms of an equation? Okay, so we have d over 50 equals to d over 65 hour, and we got to add 2 over 5 hour. This is our equation that links all of this together. Okay, so I just repeat again, how do I get this? So firstly, what I do is I I express this on one side of the equation, time taken for 50 km hour journey, alright, put as the left side. And then I know that because it takes 24 minutes faster to travel 65 km per hour journey, so I put this on the right hand side, and then I add that 24 minutes to it. Alright, because we need it to add to the right side of the equation for it to be balanced. So after I form my balanced equation, what I do is I will solve it. So firstly, let's sum up the right side. So left side still remains the same, but right side will be d over 65, and we make the denominator the same, so answer would be 65. Let me calculate. 26. Alright. Okay, good. Then we have to add the numerator, so d over 50 equals to d plus 26 over 65. Cross multiply, 65d equals to 50d plus 1300. And then if you just do a quick one, if you solve for d, you should get 86 2/3 meters, or 260 over 3 meters. Sorry, not meters, but in kilometers, because that is what we have been calculating in our question. Alright. Okay, I hope this clarifies. Now, if not too sure, let's try a similar question. So a ferry travels from island A to island B at an average speed of 40 km per hour. And if the ferry increases its speed to 50 km per hour, it will arrive 18 minutes earlier. Calculate the distance. Okay, so same thing. The distance, we let it be some unknown. Alright, let distance be okay, in this case let's use x, since we're more familiar with x. Now we got first journey and the second journey. Okay, so for first journey, the time taken for the journey would be distance divided by time. So we get x over, sorry, not distance divided by time, distance divided by speed. Okay, x over 40 km per hour, and this would be the time taken in hours. Okay, so for our second journey, the time taken for the journey would be same thing, distance over the speed would then be x over 50 hours. Alright, so now we have these two parts. Okay, how do we join them with 18 minutes? Okay, so firstly, we convert 18 minutes divided by 60 would be, let me calculate, 60, three over 10 hours. Okay, so let's form our equation. So our equation would be x over 40 equals to x over 50 hours. Okay, let me just put the units so everyone can see it better. And 3 over 10 hours. Okay, so how do I form this? This is from my first journey of 40 km per hour. This is the time taken during my second journey of 50 km per hour where it is faster. And this is the, what we call, not 3, but time saved of 18 minutes. Alright, so once I form my equation, then I can solve it. Okay, so with x over 40 equals to x over 50 plus 15 over 50. Okay, afterwards, I can just add them together. X plus 15 over 50, and then cross multiply. Okay, okay, I don't have space, so let me just move this around. And then lastly, what I should get is x equals to 60 kilometers. Alright. So just to summarize this chapter or this topic, what we did is we studied about speed, alright? And we know the formula for speed is distance over time. And using the triangle, we can calculate different aspects of speed like distance and time. Then we learn about average speed, where we calculate the total distance divided by total time. Okay. And lastly is we apply algebra into speed. Of course, this is a higher order question, so don't be afraid. We just practice and we try to understand the concept. But the main approach when we are targeting algebra question is we must first state our unknown, which is then distance, and then we must find some way to form our algebraic equation to solve it. That is when you want to find the individual time taken for each journey, and then we got to add in our difference in time. That's how we form our algebraic equation. Learn what we did in chapter 5, solving linear equations, and then we are able to get our final answer. Is that okay? Alright, if no further ado, then this is the end of our video. And if you have any things that you're unsure about, please feel free to ask me back in school. See you.